Yeah, I'm making this quick one for a friend who wants to learn how to read inputs on the PIC microcontroller. The PIC is a little bit different from the AVRs, and I just want to make this clear. Most of the times, what mistake we do is we fail to configure the ADC properly, and we have two types of configurations for the 16Fs and then for the 18Fs, as well as for the 24 and the 32s. So we're going to look at a quick one for the 16Fs, which he called for. Anyone who needs help with the 18Fs can always give me a message out, and I'm the one for 18Fs. Alright, so the first thing we're going to look for on the data sheet is going to be the ADCON0 and ADCON1. We find them on the 16Fs, and then we normally have the ADCON2 on the 18Fs. That's an additional one to do that. Alright, so we have the parameters here. It's going to be an 8-bit for ADCON0, and then ADCON1 as well is going to be an 8-bit. Alright, so you're going to look at the bits and then what they do. Alright, so the 7 and the 6-bit in terms of electronics, that's going to be the 8 and the 7-bit. For literal translation, is going to be for the clock selection. That tells you how fast the ADC is going to sample its data. We can go with the FOC divided by 2. That's going to be a clock divided by 2, or clock divided by 8, or by 32. It depends on how fast we want it. If we want to go something very fast, then that means we're going to go with 0, 0. That's going to be FOC divided by 2. So if you're running a clock of, let's say, 16 megahertz, that means it's going to sample at around 8 megahertz. That's what it's going to tell it's going to do. But then there are other calculations in terms of that using the 8 megahertz, which is going to bring it down to something low. Probably we might look at that one in a different section when we're looking at ADCs. Alright, so the next one we can go to is going to be the ADCON1, which is going to tell you what we want to do to which of the ping is, whether it's going to be an ADC or not. Alright, so here we get to set it here. So we do a right justify, we do a left justify, and what I normally go with my left justify. Some people go with the right justify. No matter what, we're still going to read our values as we want it to be done. Alright, so then we have 6 and 4 there, which is unimplemented. We can see that one here. Then we come to the most important part here. That's from bit 0 to bit 3. That's from the first bit to the fourth bit, and that determines which one goes as an analog and which one goes as a digital. Alright, so we have the map here, which tells us if we set all to zeros, and that means all our 8 analog pins are going to analog reading. Here in the case, he's doing just an IO, which means he needs a digital input there. So we're going to go with a 0, 1, 1 and an X. The X stands for I don't care, and here we're just going to go through which one of them does not implement that. So we can go through and we see rather 0, 1, 1. There's no 0, 1, 1, 0. So anything we put there, whether 0, 1, 1, 0, 0, 1, 1, 1, it would not matter. All we're going to have is going to be I don't care. So we're going to write these parameters down, and then we're going to go by it there. So we have a 0 for the first. That's our last bit there. It's going to be 0. So you're just going to go with that one. We're going to compute this into hex. We're going to convert this into hex, and then we're going to have what we want. So 0, 1, 1, 0 is going to be what we want. Alright, I program using micro C, which is easy for me. It's got a small calculator here, which I can just put whatever I want in there. So 0, 0, 0, 1, 1, 0 gives me a 6, a hex 6. And then for my ADCON0, I'm going to set everything to be 0. Yes, I'm going to set everything to be 0. Because I don't want the ADC on as well, so everything will be 0. So this is going to be my configuration here. So ADCON 0 is equal to 0, and then ADCON 1 will be equal to 0, 6. Alright, so that should be done for the configuration of the ADC. So once this is done, we can go ahead and then we set our port A to be an output, and then port B to be an output as well. Alright, so after that we can set, this is going to be setting them low, so we're going to have trace A 0, 0, and then trace B also an output. Alright, so once this is done, we can have the readings. There are two ways of doing the readings here. We can do a port A.F0, which is going to be the first bit, or F7, which is going to be the last bit, which is going to be the 8th bit. Or we can just do an RA1 underscore bit, or whatever I want to do. That primarily goes with the compiler you're using. But if you want to go, because if you're using the one coming from microchip, then that one you're gonna go with a different parameter there. Alright, so I'm going to do this. I prefer to do this a lot, so I'm going to set a variable here, which I'm going to call I'll call this one an int. Assign int. Assign int should be fine because I don't want any negative values. Okay, I'll assign int, and I'm going to call this one io underscore read one. That, and I set to no value. Over the past, we've had a couple of bugs with this, so I always call this one my zero. I mean, I don't want to have any value here, so I call io underscore read one should be equal to or a dot f0. This should read port A first bit, and that is how we read normal inputs on the microcontroller. So this is a PIC16F871. You can go ahead there and try it out. We can we compile that and there's no error. We can do something that whatever we read is going to mean it's something, but I don't have a microcontroller here to test. But then this is what it's going to be. If you have any issues, then just hit me a message. I'm going to reply to it as soon as possible. Thanks for watching. Have a nice day.